There are three methods to evaluate the design of any components, namely experimental method, whose result cannot be believed blindly until we use 3 or 4 specimens. This method is also time and resource consuming. Numerical method, where we use certain specialized software to calculate the result on the whole body. And lastly, analytical method, where we use certain formulas and calculate the result only on the certain points. There are various types of numerical methods, some of which are FEM, BEM, FVM and FDM. FEM, finite element analysis, finite element method, both are the same. One term is used in the industries and other term is used in the universities. In the finite element method, we use discretization process to recreate the geometry by the help of element. The vertices of element used as the calculation point and whose results are interpolated on the whole body. Boundary element method, where we calculate only on the boundary of the geometry, and the mesh is also carried on the boundary in the boundary integral form. This method is much faster but can be used only in the geometry or situation where the boundary element matters more than the inside of geometry, or where we need only the result from the boundary of the surface. Finite volume method. Computational fluid dynamics program uses this method, where we consider finite volume method having a small element volume element. It is based on Navier-Stokes equations. In the case of CFD, variable property across the nodes are the area, pressure, volume, etc. Finite difference method. It is the way of solving the partial differential equations using Taylor series to convert them into the linear equations. It is generally used in the CFD problem coupled with the thermal problems. In the case of FVM, we carried out meshing to discretize the whole geometry into smaller elements to carry out the calculation at its grid points called as nodes. Because for a continuous object, it is very difficult to calculate on each and every points, because it has infinite points, and to solve at infinite points it needs infinite many equations. In FEM, the software solves only on a certain grid points, generally located on the vertices of an element, and interpolate the result on the whole body using this interpolation formula. In the case of quad for element in 2D meshing, and using this formula in the quad at elements. As we all know, DOF is the minimum parameter required to define the motion of a body, and there may be infinite degree of freedom, but in FEA software there are only 6 degree of freedom possible, which is XYZ translation and XYZ rotational. Now for defining a shape, there are 3 types of element that are classified into 1D, 2D and 3D. This is a 1D element. When we mesh this line element, we get a line, and we have to put the additional information as area of cross section to define the whole geometry of line. Geometries like beam column can be easily defined with the line elements. In the case of 2D types of element, there are 2 types of elements are possible. This one is tria and another is quads. Tria have 3 sides and quad have 4 sides, and additional information required by the user is its thickness of 2D geometry. Components like spur gear can easily defined by the 2D geometry with additional data as thickness. Thus this can be easily modeled by the 2D types of elements. In the case of more complex geometry, we prefer to use 3D types of element. There are 4 3D types of elements possible. The first one is hex element, which have 6 faces. This one is penta, it has 5 faces. This one is pyramid, it has the 5 faces as shown here. And this one is tetra element, having 4 faces. There are other types of element like mass, spring, gap, rigids, etc.